students, in my last videos, we have discussed the concept of chemical bonding. Okay. Today I am going to start the next topic from the chapter of chemical bonding and molecular structure, that is shapes of molecule. Okay students, covalent molecules exhibit variety of shapes owing to the directional nature of the covalent bonds. Okay, the covalent bonds having directional nature, therefore the covalent molecules adopt different shape. This property arises because pairs of electrons occupy orbitals which repel each other so that they are oriented in space as far as possible. Okay? The definite relative arrangement of bonded atoms in a molecule is known as geometry or shape of molecule. Sidgwick and Powell, the two famous scientists, Sidgwick and Powell, proposed a simple theory based on repulsive interactions of the electron pairs on the valence shell of the atoms. They proposed that the shape of molecule can be determined by the number of electron pairs in the valence shell of central atom, and proposed a theory known as valence shell electron pair repulsion theory. Okay? Yes, then on the basis of the valence shell electron pair repulsion theory, we can explain the shapes of different molecules. Okay, then what are the important postulates of valence shell electron pair repulsion theory? It's short form Vsepr theory. Postulate number 1. The shape of a molecule depends upon number of electron pairs, bond pairs and lone pairs around the central atom in a molecule. That is the first postulate. The shape of a molecule depends upon number of electron pairs, bond pair and lone pair around the central atom in a molecule. The second postulate, the electron pairs surrounding the central atom repel each other. As a result, the electron pairs try to stay as far apart as possible to acquire a state of minimum repulsion or maximum stability. Okay, the electron pairs surrounding the central atom repel each other. As a result, these electron pairs try to stay as far apart as possible to acquire a state of minimum repulsion or maximum stability, and the repulsive interaction decreases in the order lone pair, lone pair, lone pair, bond pair and bond pair, bond pair. And the third postulate is the presence of lone pair of electrons in addition to bond pair causes certain distortion in the regular shape of molecule. Okay, due to the strong repulsive interaction from the lone pair of electron, the shape of molecule gets distorted. Yes. Then the fourth postulate, after this repulsion, electron pairs around the central atom directed towards some preferred position in space to acquire a definite geometry. Okay? After the repulsive interaction, these electron pairs around the central atom directed towards some preferred position in space, and the molecule acquire a definite geometry or a definite shape. Let us study the shapes of molecules containing only bond pairs of electrons on the basis of valence shell electron pair repulsion theory. Okay? Vsepr theory helps to predict the geometry of different molecules. Okay, then please consider the following examples. The first example is BeF2 or BeCl2. Okay, BeF2 or BeCl2, beryllium chloride or beryllium fluoride. Okay, in BeCl2, the central atom is beryllium. The atomic number of beryllium is 4. Its electronic configuration is 2, 2. That means what? Beryllium atom has 2 electrons in its valence shell. Beryllium atom has 2 electrons in its valence shell. In the formation of BeCl2, each of these valence electron is shared by each of 2 chlorine atoms. Yes. The central atom, beryllium, shares its 2 valence electrons with chlorine atoms. Okay? The 1 valence electron of 1 chlorine atom is shared with the 1 valence electron of beryllium. That means in BeCl2, the central beryllium atom is surrounded by 2 bond pairs of electrons. Okay, there is no bond pair, only bond pair. 2 bond pairs of electrons. Okay, what is the first postulate of Vsepr theory? The shape of a molecule depends upon the number of electron pairs around the central atom in a molecule. That means, in this case, the shape of BeCl2 depends upon, yes, the 2 bond pairs of electron present around the central atom beryllium. Then what is the second postulate? The electron pairs surrounding the central atom repel each other. We know the electrons are, or the electron clouds are negatively charged. Okay, then yes, this negatively charged electron cloud, this bond pair of electron, this electron pair around the central atom beryllium repel each other. Okay, yes, that means what? When attractive force increases, stability increases. But when repulsive force increases, repulsive force in a system increases, stability decreases. Okay, then here, in order to attain the maximum stability, these electron pairs try to stay as far apart as possible. Then repulsive force become minimum, repulsive force decreases and stability increases. Okay, that is the second postulate. The electron pairs surrounding the central atom repel each other. As a result, the electron pairs try to stay as far apart as possible to acquire a state of minimum repulsion or maximum stability. Yes. In BeCl2, we can say that to minimize repulsion and to have maximum stability. Yes. These two bond pairs of electrons. Okay? Yes. Attains linear shape like this. Linear shape. That means we can say that, yes, to minimize repulsion, the two chlorine atoms are placed on the opposite sides of beryllium atom. Okay? Then the angle between these two bond pair, Be single bond Cl, Be single bond Cl, the angle between these two bond pair is 180 degree and it attains linear shape. Okay. Already we studied the bond angle determines shape of molecule. Here the bond angle is 180 degree. Okay. And BeCl2 attains linear shape. BeCl2 attains linear shape. Okay. That means we can say that if the number of bond pairs of electron around the central atom is 2, it adopts linear shape, it acquires linear shape with the bond angle 180 degree. Okay. Second example is BF3. In BF3, the central atom is boron. Boron, its atomic number is 5 and its shell-wise electronic configuration is 2, 3. Okay. That means what? The central atom, boron, has 3 electrons in its valence shell. Yes. Then this boron atom shares its 3 valence electron with the 3 electrons of 3 fluorine atoms. 3 fluorine atoms. Then in BF3, the central boron atom is surrounded by 3 bond pairs of electrons. Okay. Then according to Vsepr theory, to minimize repulsion and have maximum stability, these 3 bond pairs of electrons, okay, are directed towards the 3 corners of an equilateral triangle. Okay, these 3 bond pairs means here 3 BF single bonds. Okay, these 3 bond pairs or 3 yes, bond pairs directed towards 3 corners of an equilateral triangle. The 3 corners of an equilateral triangle with bond angle 120 degree. Yes. That means here the 3 fluorine atoms are placed at the 3 corners of an equilateral triangle. Okay. Then, therefore, we can say BF3 molecule has trigonal planar structure. Yes. Trigonal planar structure. Trigonal planar structure with the bond angle 120 degree. Then we can say that, yes, if yes, number of electron pairs around the central atom is 3, it acquires trigonal planar shape with the bond angle 120 degree. Next molecule is methane CH4. In CH4, the central atom is carbon. The atomic number of carbon is 6. Okay, its electronic configuration is 2, 4. Then we can say that in CH4, the central carbon atom has 4 valence electrons. The central carbon atom has 4 valence electrons. All these 4 valence electrons are shared with 4 hydrogen atoms. 4 hydrogen atoms. Okay, that means all these all the 4 valence electrons are bonded to 4 hydrogen atoms, forming 4 CH bonds, 4 CH single bonds. Okay, that means in CH4 the central carbon atom is surrounded by 4 bond pairs of electrons. Then according to Vsepr theory, to minimize repulsion, these 4 bond pairs of electrons are directed towards the 4 corners of a tetrahedron. The 4 corners of a tetrahedron with a bond angle 109 degree 28 minutes. Okay, that means in CH4 the 4 CH bonds are directed towards the 4 corners of a tetrahedron. Here the 2 CH bonds lie, these 2 CH bonds, please listen, lie in the same plane. One CH bond lies towards the observer, towards you, yes. Then the next CH bond lies away from the plane. Okay, then it acquire tetrahedral shape. Tetrahedral shape, here the bond angle, the angle between the 2 bond pairs of electron, 109 degree 28 minutes. Then we can say that, okay, if the number of bond pairs of electrons around the central atom is 4, it acquires tetrahedral shape. Tetrahedral shape with the bond angle 109 degree 28 minutes. So here the shape of methane is tetrahedral and the bond angle is 109 degree 28 minutes. Okay. Next molecule PCl5, phosphorus pentachloride. In PCl5 the central atom is phosphorus. The atomic number of phosphorus is 15. Its electronic configuration is 285. Okay. Already we have learned that the PCl5 is an example for super octet molecule. Yes. In PCl5 the central phosphorus atom has more than 8 electrons in its valence shell, that is 10 electrons in its valence shell. Okay. Then in PCl5 the central phosphorus atom has 5 electrons, 1, 2, 3, 4, 5 electrons in its valence shell. Then this 5 electron is mutually shared with the 5 electrons of chlorine atom. Yes. In PCl5 the central phosphorus atom is surrounded by 5 bond pairs of electrons. Then according to Vsepr theory, to minimize repulsion, these 5 bond pairs of electron directed towards the 5 corners of a trigonal bipyramidal. Okay. Then in this geometry, 3 bond pairs of electrons or 3 PCl bonds directed towards the 3 corners of an equilateral triangle. Okay, this bond is called equatorial bond. The 3 PCl bonds lie in the same plane of a triangle. the three PCl bonds lying in the same plane of a triangle are called the equatorial bond. Equatorial bond. And okay, the angle between these three equatorial bonds, the three PCl bonds, directed towards the three corners of an equilateral triangle. These three PCl bonds lie in the same plane. These three PCl bonds are called the equatorial bond. And here the angle between the two PCl bonds are 120 degree. Yes. Then the remaining two PCl bonds. So we can say the remaining two bond pairs of electrons. Okay, the remaining two PCl bond, please listen, lie perpendicular to this plane. Okay, perpendicular to this plane. One PCl bond lie above the plane, and the other PCl bond lies below the plane. Okay, these two PCl bonds lie perpendicular to this plane, and these two PCl bonds are called axial bonds. Axial bonds. Three PCl bonds are called equatorial bond, and these two PCl bonds are called axial bonds. Okay. Then here the angle between one axial bond and one equatorial bond, okay, is 90 degree. In 90 degree, okay, that is in PCl bond. Three chlorine atoms lie on the same plane, making an angle 120 degree, and the other two PCl bonds or other two chlorine atoms are arranged perpendicular to this plane, making an angle 90 degree. Okay, then the shape of PCl5 is triagonal bipyramidal. PCl5 adopts a triagonal bipyramidal shape. Okay, here the shape is triangle bipyramidal. Okay, then we can observe a common base, a triagonal base. Okay, then two pyramids. We can draw the imaginary line. Okay, then one pyramid above and one pyramid below this triagonal base. The common base, triangle base, then two pyramids. Then we can say that the shape of PCl5 is triagonal bipyramidal. That means what? Yes, according to Vsepr theory, if number of bond pairs of electrons around the central atom is 5, it adopts triagonal bipyramidal geometry. Okay, next molecule is SF6. In SF6, central atom is sulfur. Okay, in SF6, sulphur hexafluoride, the central atom is sulfur. The atomic number of sulfur is 16. Its electronic configuration is 286. Then we can say that in SF6, the central atom, sulfur has 1, 2, 3, 4, 5, 6 valence electrons. Okay, 6 valence electrons. Okay, then all these 6 valence electrons are bonded to 6 fluorine atoms. Okay, 6 fluorine atoms. 6 fluorine atoms to form 6 SF bonds. 6 SF bonds. That means here we can observe the 6 bond pairs of electrons around the sulfur atom. Okay, all these 6 valence electrons are bonded to 6 fluorine atoms, forming 6 SF bonds, 6 sulfur fluorine bonds around the sulfur atom. Then according to Vsepr theory, to minimize repulsion, these 6 SF bonds directed towards 6 corners of an octahedron. 6 corners of an octahedron. Okay? Yes, with making bond angle 90 degree. Okay, then S of 6 acquire octahedral geometry with bond angle is 90 degree. Okay, that means octahedral shape has 8 triangular faces. 8 triangular faces. Okay, we can draw one triangular face like this. Okay, like this. Okay, 8 triangular faces. 8 triangular faces and 6 corners. Yes. That means an octahedral shape has 8 triangular faces or 8 triangular faces and 6 corners. Then on the basis of Vsepr theory, we can say that if number of bond pairs of electron around central atom in a molecule is 6, it acquires octahedral shape. Okay? Yes. Next, let us discuss the shape of molecules containing both bond pairs and lone pairs. The first example is Nh3 Ammonia. In Nh3, the central atom is nitrogen. Its atomic number is 7. Electronic configuration is 2,5. Then we can say that in Nh3, the central nitrogen atom has 5 valence electrons. Out of these 5 valence electrons, the 3 electrons are used for making single bond with the 3 hydrogen. Yes, 3 hydrogen. Okay, 3 hydrogen. Then the remaining 2 electrons exist as lone pair of electrons. That means ammonia has 3 bond pair and 1 lone pair. Okay, then actually here the number of electron pairs around the central atom is 4. Then according to Vsepr theory, the expected shape is tetrahedral. The expected shape is tetrahedral shape. Then you please read these 2 postulates. The second postulate, the last part, the repulsive interaction decreases in the order lone pair, lone pair, lone pair, bond pair, bond pair, bond pair. That means we can observe the strong repulsion between 2 lone pairs and weak repulsion between 2 bond pairs. And the third point, the presence of lone pair of electrons in addition to bond pair causes certain distortion in the regular shape of molecule. Okay. The presence of lone pair of electrons in addition to bond pair, it may cause certain distortion in the regular shape of molecule. Actually, the regular shape of ammonia, the expected shape of ammonia is tetrahedral. The reason is that in ammonia the central atom is surrounded by 4 pairs of electrons, 3 bond pair and 1 lone pair, total 4 pair. The expected shape is tetrahedral. But this lone pair can exert strong repulsion. Due to the strong repulsion from the lone pair, the three bond pair come closer. The three bond pair come closer. Yes. Then the shape get distorted to pyramidal shape. Please listen. Actually the expected shape like this. Okay. This is a lone pair, three bonds, tetrahedral shape. But due to strong repulsion from this lone pair, these three bond pair, these three NH bonds come slightly closer. Yes, come closer, and it adopts pyramidal shape with bond angle 107 degree. Yes. Okay. That means on the basis of Vsepr theory, we can say that the presence of lone pair of electron in addition to bond pair causes certain distortion in the regular shape of molecule. Okay. And we can say that if a molecule has three bond pair and one lone pair around the central atom, the shape is pyramidal. The shape is pyramidal and the bond angle is 107 degree. 107 degree. Okay. Then the last example is H2O. The next example is water. In water, the central atom is oxygen. Atomic number of oxygen is 8. Its electronic configuration is 2,6. Then, out of these 6 electrons, 2 electrons are used for making single bond with the 2 hydrogen atom. That means in water, the central oxygen atom is surrounded by 2 bond pair and 2 lone pair. Actually, the central oxygen atom is surrounded by 4 pairs of electrons. Then the expected shape is tetrahedral. But in water, all 3 types of interactions are possible. Lone pair, very strong interaction, lone pair, then lone pair, bond pair, and bond pair. Then this, due to the presence of the strong repulsive interaction from these 2 lone pair of electron, the 2 OH bonds come closer, and the shape get distorted to V shape or bell shape with bond angle 104.5 degree. Okay, that means if a molecule has 2 bond pair and 2 lone pair around central atom in a molecule, it acquires V shape or bend shape, V shape or bend shape with bond angle 104.5 degree. Okay, then the shape of water molecule is V shape or bend shape. The bond angle HOH bond angle in water is 104.5 degree. Okay, students, goodbye, study well.